Course 2, Lesson 2, we are looking at operations of arithmetic. Kind of a deceiving title because really what the focus is all of the different properties that we have with our operations. So when we look at our different properties that we have, you can see that some of them are pretty familiar. Things like the commutative property. So we have the commutative property with both addition and multiplication. And so what these are saying is that when we are adding things, all right, so 5 plus 2 plus 3, or 3 plus 5 plus 2, those will give us the same sum. We can add in any order, and it will give us the same thing. Same with multiplication. Regardless of what order we have it in, it will end up the same product, which makes our lives a lot easier, especially when we see problems like, let's say we have, 97 plus 16 plus 3. Well, instead of trying to go and say, all right, what is 97 plus 16? I am going to rearrange these. Say, how about we do 97 plus 3 and then add 16? Well, we know that 97 plus 3 is 100, which makes our lives a lot easier when we want to add 16 to say that we have 116. Same thing with multiplication. Let's say we have a problem that says 27 times 15, or sorry, let me change this a little bit. How about 25 times 15 times 4? Well, I don't know about you, but 25 times 15 off the top of my head, it's not as easy as maybe 25 times 4. So I'm going to rearrange. Do 25 times 4 times 15. So now when I do it, I get 100 times 15, which gives me an answer of 1,500. Okay? A whole lot easier than going the long way around, okay? At least in my perspective. That's what we can do with the commutative property. Other properties that we have the associative property. This is where we can change the grouping of addition and change the grouping of multiplication, and we won't change anything. So regardless if we group 5 and 3 and then add 2, or we group 3 and 2 and add 5, it won't change the sum. Similarly, with our associative property, with multiplication, we can multiply 5 and 3 first or 3 and 2 first. It won't change the product. It makes our lives a whole lot easier, just like those other examples that I just showed. So when we look at these different examples, we can define them based on if they are showing the commutative property or the associative property. So if we look at the first one, we look and we see parentheses. Well, that automatically says, well, maybe it's associative, but we can't tell just quite yet. Let's look at what's inside of those parentheses. In this one, the first one, we have a 3 and a 3. In the other side, we have a 3 and a 2, meaning that we have the grouping changed. So yes, we actually do have the associative property. Our grouping is different. The next one, we see that we have multiplication. Well, that's good. Either of them can be with commutative or associative with multiplication. But let's maybe, since there's no parentheses, look at the order. In the first part, we have 4, 5, 6. And in the next part, we have 6, 4, 5. Using those same numbers but a different order means that we have the commutative property. Okay, let's keep going. Well, we see parentheses, so maybe we're thinking it's associative. So let's look and see if those parentheses are grouping anything different. In the first part, we have 8 and 2. In the second part, we have 8 and 2, which means we didn't change the grouping. So maybe, instead of changing the grouping, maybe we changed the order. And we do see that we did change the order. We have 8 plus 2 first, and then we're going to add 3, whereas the second one, we're adding 3 outside first plus that parenthesis. So we changed the order, which means that we have the commutative. We are able to move those around. If you're following along, the next one, we changed the grouping, which means we have the associative property. And the last one here, we also changed the grouping, so we have the associative property. But if you notice, it is also the commutative property because the order has changed in there. 2, 3, 9, and we have 3, 9, 2, along with having different groupings. So we actually see both in this case. Okay, so we have the commutative property, the associative property, but we also have other properties, things like the identity property of multiplication. Just like you have an identity. You have a personality, you have a name. Those are part of your identity. Well, a number has an identity as well. Okay, it has a value. And with multiplication, there's a certain way that I can keep that identity even by multiplying it by something. And that's by multiplying it by 1. If we take any number for a, multiply it by 1, we will still get a. The identity doesn't change. So 8 times 1 equals 8. Maybe we have an example of negative 23 times 1 equals negative 23. Okay. And we have lots of other examples. 143 times 1 equals 143, and so on. All right? Any number times 1 gives us itself. Okay? Similarly, with addition, we also have an identity property of addition. Okay? This means that even when we add something to a number, it keeps its original value. And as you can imagine, that would mean that we are adding 0. Any number plus 0 gives its original identity. So 8 plus 0 equals 8. Negative 23 plus 0 equals negative 23. 143 plus 0 equals 143. There are infinite amount of examples here that we can take a number, add 0, and it stays the same. That is the identity property of addition. Okay, so we have our identity properties of both multiplication and addition again. So remember, commutative property, associative property, identity properties are all with multiplication and addition. All right. Lastly, we have 0 properties. Sorry about that, there's an announcement going on. So we have the 0 property of multiplication. So if we look at this, what this means is that when we are all said and done with what we're doing, it's going to equal 0. So if we take a number, multiply it by 0, it's going to give us 0. All right? Our outcome is going to be 0. That's why we call it the 0 property of multiplication. All right? So if we take 8 times 0, it's going to equal 0. Negative 23 times 0 is going to give us 0. Negative 23, let's see if I can get it to right. There we go. Negative 23 times 0 is going to give us 0. Our 143 times 0. I'm not sure why this is happening, but I'll try to get it figured out. Okay. Any number times 0 is going to give us 0. Okay. So the 0 property of multiplication. These are all our different properties that we have. Now, I could add another one of the 0 property of addition. Okay, and we could say that is if we take a number and its opposite, add them together, it's going to give us 0. All right? That's our other 0 property. Okay? So if we look at a bunch of these, we can define them really quick. This one up here, well, if we are taking a number, multiplying it by something, and we still get the original number, that's going to be an identity property. If we can switch the order, that's going to be commutative. If we can switch the order again, it's still going to be commutative. If we take this and start grouping things differently, that's the associative. If we can switch the order with addition, that's commutative. If we can take a number, add 0, and we still get the original number, that's an identity property of addition, of course. If we switch the order, okay, another example of commutative property. If we look at this one, we haven't switched any order, but we have grouped it differently. So that's the associative. And lastly, this 5 times 0 equals 0. Since we have an outcome of 0, this is called a zero property. Okay, so just some examples of all of those properties all together. All right, when we look at our different types of operations with addition, subtraction, multiplication, division, each of these has different names related to it. If we're looking at our sum, that means that we have an addend and an addend added together. With a difference, we have a minuend minus a subtrahend. Product, we have a factor times a factor. Quotient, we call this a dividend divided by a divisor. What you'll notice is that when we talk about all of these properties, we're really only looking at the ones that are addition and multiplication. And a lot of what we looked at was the fact that we can switch the order of these. We can switch the order of addend and addend, factor and factor. Well, that's good because we have the same names. It wouldn't make much sense if we had the commutative property for subtraction and we were able to somehow randomly switch these names. No, it's good that our addition has the same names between and our multiplication has the same names. Okay? All right. Lastly, let's look at a couple examples of using these words in a problem. So this says, what is the quotient when the product of 3 and 6 is divided by the sum of 3 and 6? Well, based on what we know about these words, a quotient means we're going to divide. All right, quotient, we're going to divide. A product, we're going to multiply. Okay, and sum, we are going to add. So let's do some of those things. The product of 3 and 6, that means we're going to take 3 times 6, and since we're using a quotient and we're going to divide it by something, well, that divided by something is 3 plus 6, since that's our sum. We just now have to simplify. Well, we need to do that multiplication first, okay? And since that 3 plus 6 is in its own denominator, we need to simplify that, and we just divide and get 2. Okay? Using the words that we know about each of these to create a word picture of what's going on. And we kind of went over one of these, 25 times 15 times 4. We would probably use the commutative property and a little bit of the associative to say, I'm going to switch the order and say this is 25 times 4 times 15, so that I can say I want to do these two first to get 100. And then I'm going to multiply by 15 to get 1500. All right, the commutative property is the main one here, but a little bit of the associative property as well. Lastly, knowing our parts of arithmetic make solving equations a lot easier. If we know that 6 and x are the addends to get us a sum of 30, well, we know that we can use our logic to say 6 plus something is going to give us 30. And we can say, well, that x needs to be 24 to give us the correct addend. Similarly, 6y equals 30. I have a factor of 6 and a factor of y that give me a product of 30. Well, logically, the only factor that would work in the place of y would be 5, because 5 times 6 gives us 30. Knowing our parts of our sums, products, differences, and quotients is going to help us later on. I hope this was useful for your homework and for studying.